Hello and welcome to Lesson Information Security Standards. In this lesson, we're going to look at how to apply information security standards and U.S. compliance laws to real-world applications in both the private and public sector. Key concepts are the International Information Security Standards and their impact on IT infrastructures, ISO 17799, ISO/IEC 27002, and Payment Card Industry Data Security Standards or PCI DSS requirements. It is nearly impossible to purchase all hardware and software from one vendor. Today's organizations get parts of their IT infrastructure from multiple vendors and expect these products to work together. How can so many products from different vendors work together? They work together because of standards. Standards are necessary to create and maintain a competitive market for hardware and software vendors. Standards also guarantee compatibility between products from different countries. They provide guidelines to ensure that products in today's computing environment work together. Several organizations develop and maintain standards for computers. In this lesson, I'm going to teach you about the common standards for computer and networking products and services. You will specifically learn about those standards that relate to security. The earliest computers were custom built for specific reasons. Designers decided how to connect components and how they communicated based on the specific computer's needs. Soon, however, designers realized that by implementing communication standards, they could enable different vendors' components to work together. This standardization increased customer confidence in computers. Customers felt more comfortable buying products based on standards. Some proprietary systems, however, did not support standards. Adhering to standards is necessary to increase market appeal and, in many cases, to comply with regulations. It is important that you know about the most influential organizations that develop and maintain the standards that govern various aspects of computing and network communications. I'm going to talk about each one of these standards that you see on this slide. Let's begin with NIST. The National Institute of Standards and Technology, or NIST, is a federal agency within the United States Department of Commerce. It was founded in 1901 as the National Bureau of Standards, or NBS. NIST was the United States' first federal physical science research laboratory. NIST's mission is to promote U.S. innovation and industrial competitiveness by advancing measurement science, standards, and technology in ways that enhance economic security and improve our quality of life. NIST provides standards for measurement and technology on which nearly all computing devices rely. In addition, NIST maintains the atomic clock that keeps the United States official time. Although NIST is a non-regulatory agency, many organizations respect and adopt its publications. NIST executes its primary mission through 4 cooperative programs. First is the NIST Laboratories. Laboratories that conduct research to advance U.S. technology infrastructure is the NIST Laboratories. The nation's industry uses this infrastructure to improve the quality of products and services. Next, we have the Baldrige National Quality Program, a national program that empowers and encourages excellence among U.S. organizations, including manufacturers, service organizations, educational institutions, healthcare providers, and nonprofit organizations. It also strives to increase quality and recognize organizations that achieve quality goals. Next, we have the Hollings Manufacturing Extension Partnership, a network of centers around the nation that offer technical and business assistance to small and medium-sized manufacturers. And finally, we have the Technology Innovation Program, another national program that offers awards to organizations and universities to support potentially revolutionary technologies that apply to critical needs of national interest. NIST maintains a list of standards and publications of general interest to the computer security community. NIST established this collection of documents called the Special Publication 800 series in 1990 to provide a separate identity for information technology security publications. The publications in this series report on research and guideline efforts related to computer security in government, industry, and academic organizations. Many in the field refer to publications in the 800 series by the name NIST SP. For example, many people refer to the documents entitled NIST Special Publications 866 as NIST SP 800-66. By the way, NIST SP 866 contains introductory guidance for complying with HIPAA. The NIST Special Publication 800 series contains many standards that provide guidance for information system security activities. Starting in 2015, NIST initiated a sub-series of special publications, SP 1800, the NIST Cybersecurity Practice Guides. SP 1800 extends SP 800 and targets specific issues relating to implementing cybersecurity to the public and private sectors. You should look up the various well-known SP 800 series and even the 1800 series as well. The International Organization for Standardization, or ISO, formed in 1946. It is a non-governmental international organization. Its goal is to develop and publish international standards. ISO, based in Geneva, Switzerland, is a network of 161 national standards institutes. ISO serves as a bridge between the public and private sectors. Some members are governmental entities, others are in the private sector. ISO's goals are to develop standards that do not cater to either group exclusively, but reach consensus. Although the organization's short name, ISO, appears to be an acronym, it's not, because ISO is an international organization. Its full name is different depending on the language. ISO members agreed on the short name ISO, derived from the Greek word isos, which means equal. ISO strives for consensus even in the choice of its name. This focus on consensus is what makes ISO such a successful authority in developing and promoting standards in many areas. ISO publishes many standards for nearly all industries. For example, the International Standard Book Number, or ISBN, is an ISO standard. For those in information technology, perhaps the best known ISO standards is the Open Systems Interconnection and Reference Model, or OSI model. This internationally accepted framework of standards governs how separate computer systems communicate using networks. The reference model contains 7 distinct layers that address 7 different issues related to network communications. The reference model defines the standards that enable computers and devices from different vendors to communicate. This is the model. Each layer in the model represents a collection of related functions. Each function provides services to the layer immediately above it and receives service from the layer immediately below it. For example, the transport layer, layer 4, provides error-free communications across the network. It also provides the connections needed by software functions in the session layer, layer 5. In addition, it calls functions in the network layer, layer 3, the next layer down, to send and receive packets that make up the contents of the network communication. Although many newer networking solutions do not strictly correspond to a structure of 7 distinct layers, the OSI reference model is still the predominant tool used to teach networking concepts. The OSI reference model has long been the basis of understanding how networks provide general services in a standard environment. Even though other models may map more directly to current software, the OSI reference model is still a relevant tool to teach networking fundamentals. ISO organizes its many standards by both the International Classification for Standards, or ICS, and the Technical Committee, or TC, to which it assigns each standard. You can find standards spread among 40 different level 1S ISCs assigned to 1 or over 200 TCs. This gives you a feel for the breadth of standards. The International Electrotechnical Commission, or IEC, is a standards organization that often works with the ISO. The IEC is the preeminent organization for developing and publishing international standards for technologies related to electrical and electronic devices and processes. People refer to the collective body of knowledge addressed by the IEC as electrotechnology. The IEC formed in 1906 to address issues with the expanding technologies related to electrical devices. Today, the IEC standards address a wide variety of areas, including things like power generation, power transmission and distribution, commercial and consumer electrical appliances, semiconductors, electromagnetics, batteries, solar energy, and telecommunications. The IEC was instrumental in the development of standards for electrical measurements, including Gauss, Hertz, and Weber. The IEC works closely with ISO and the ITU-T, which I'm going to discuss later in this lesson, to synergize efforts. To ensure international acceptance and maximum uses of its standards, the IEC encourages participation from as many countries as possible. There are approximately 64 IEC members, also called National Committee or NCs, and 23 associate IEC members. In 2001, the IEC expanded its membership to include more developing nations. The affiliate country program includes about 84 smaller countries. As an IT professional, you will most likely encounter IEC standards related to physical computer and networking hardware. The focus of the IEC has expanded since its inception as the electrical and electronics industries have changed. Today, much of the IEC's focus includes standards that address emerging power needs and how they affect other functional areas. The IEC is active in developing standards that support safety, performance, environmental responsibilities, energy efficiency, and renewable energy sources and use. The World Wide Web Consortium, W3C. The creation of the World Wide Web in 1990 marked a turning point in the way users access resources on the internet. In the early days of the internet, competing vendors released their own versions of the primary language of the web, Hypertext Markup Language, or HTML. These versions were incompatible with those of other vendors. These incompatibilities caused issues with web browsers and limited the web's functionality. As interest in the web grew, the need to standardize its primary language became clear. So Sir Tim Berners-Lee, the computer scientist who wrote the original proposal for what eventually became the World Wide Web, founded the World Wide Web Consortium, or W3C, in 1994 to address the lack of standards. The W3C immediately became the main international standards organization for the World Wide Web. The stated purpose for W3C is to develop protocols and guidelines that unify the World Wide Web and ensure its long-term growth. The W3C currently has 419 members, or somewhere around that number, representing businesses, nonprofit organizations, universities, and various government agencies. The W3C develops many web-related standards that govern and coordinate many aspects of web development and operation. Standards in the W3C has developed or endorsed include the following. You have the Cascading Style Sheets, or CSSs. You have Common Gateway Interface, or CGI. You have Hypertext Markup Language, or HTML. You have Simple Object Access Protocol, or SOAP. You have Web Services Description Language, or WSDL. And you have Extensible Markup Language, or XML. Each of these standards that I named and specifications is necessary to ensure that web applications interact with web components from other vendors. If you work with any World Wide Web components, you will likely encounter one or more W3C standards. The Internet Engineering Task Force, or IETF, develops and promotes Internet standards. According to the IETF website, the organization's purpose is to make the Internet work better. The IETF focuses on the engineering aspects of Internet communication and attempts to avoid policy and business questions. The IETF works closely with the W3C and ISO/IEC, focusing primarily on standards of the TCP/IP, or Internet Protocol Suite. The IETF is an open organization. There are no membership requirements. All participants, including contributors and leaders, are volunteers. Their employers usually fund their work. The IETF first met in 1986 as a group of 21 researchers who wanted to formalize the main internet communication protocols. Today, the IETF is a collection of working groups, we call these WGs, with each group addressing a specific topic. There are currently more than 100 WGs. Because WGs tend to operate independently, the IETF set minimum standards for each group. Each WG has an appointed chair or group of co-chairs and a charter that documents the group's focus and expected deliverables. Every WG has a dedicated mailing list to which anyone can subscribe. These WG mailing lists serve as the primary communication medium for participants. Most participants get started by simply subscribing to one or more WG mailing lists of interest. WGs also hold periodic meetings which are open to all participants. Although it is generally beneficial to attend meetings, it is possible to participate in the WG by just interacting via the mailing list. Request for comments. So the IETF produces requests for comments, or RFCs. An RFC is a document that ranges from a simple memo to several standards documents. Each RFC's introduction indicates its status. The RFC model allows input from many sources and encourages collaboration and peer review. The IETF publishes guidelines for RFCs. Here are a few points about RFCs. Only some RFCs specify standards. Only RFCs that open with phrases like "this document specifies" or "this memo documents" should be considered standards or normative documents. RFCs never change. Any change to an RFC gets a new number and becomes a new RFC. Always look for the latest RFC because previous documents may be out of date. RFCs may originate with other organizations. The IETF creates only some RFCs. Others may come from independent sources, the IEB or the Internet Research Task Force, IRTF. RFCs that define formal standards have 4 stages. As an RFC moves from one stage to the next, it becomes more formal and more organizations accept it. The stages are as follows. proposed standard first. This is the initial official stage of a standard. Then we move to the draft standard. You see this at the bottom of the slides, by the way. This is the second stage of a standard, after participants have demonstrated that the standards have been deployed in working environments. Next, you move to the standard, the SDT, the final stage of a standard after it has been shown to be widely adopted and deployed. We also have best current practices, the alternative method used to document operational specifications that are not formal standards. Some examples of IETF standards include RFC 5878 and RFC 5910. RFC 5878 is called the Transport Layer Security Authorization Extensions, or TLS. This contains the specification for extensions to the TLS handshake protocol. RFC 5910 is called the Domain Name, or DNS Security Extensions mapping for the Extensible Provisioning Protocol, or EPP. It describes EPP extension mapping for DNSSEC domain names stored in a central repository. Neither of these RFCs make for lightweight reading. They contain very technical detail that define how the Internet operates. The Internet Architecture Board is a subcommittee of the IETF. It also serves as an advisory board to the Internet Society, or ISOC. The IAB is composed of independent researchers and professionals who have a technical interest in the well-being of the Internet. The IAB serves as an oversight committee for many IETF activities. The IAB provides oversight for the following: architecture for Internet protocols and procedures, processes used to create standards, editorial and publication procedures for RFCs, and confirmation of IETF chair and technical area directors. The IAB provides much of the high-level management and validation of the processes of conducting IETF business. The IAB is an important committee that has substantial influence over many standards that affect the Internet. According to its website, the Institute of Electrical and Electronics Engineers is the world's largest professional association for the advancement of technology. The IEEE is an international nonprofit organization that focuses on developing and distributing standards that relate to electricity and electronics. With more than 420,000 members in approximately 160 countries, it has the largest number of members of any technical professional organization in the world. The IEEE formed in 1963 through the merger of two older organizations, the Institute of Radio Engineers formed in 1912 and the American Institute of Electrical Engineers formed in 1884, is indeed a large group. The IEEE supports 39 societies that focus activities on specific technical areas. These technical areas include magnetics, photonics, and computers. Each society develops publications, holds conferences, and promotes activities and events to further knowledge and interest in a specific area. IEEE also provides many training and educational opportunities covering a large number of engineering topics. IEEE is also one of the largest standard producing organizations. The IEEE Standards Association, or IEEE.SA, which you see at the bottom of the screen, manages these standards. IEEE standards cover many industries, including information technology. IEEE currently publishes or sponsors more than 1,300 standards and projects. The best known standard that relates to information security is the IEEE 802 LAN-MAN standard family. This group of standards defines how various types of local area networks, which are LAN, and metropolitan area networks, which are MAN, protocols work. This table you see before you lists some of the more recognizable working groups in the IEEE 802 LAN-MAN standard. IEEE is open to members from the technical community who meet certain professional requirements. Full members can vote in IEEE elections. Students can obtain student memberships in IEEE. They can enjoy all the benefits of full membership except the right to vote. For interested parties who are not students and do not meet the technical requirement, IEEE offers associate memberships with limited privileges. I mentioned this one earlier. It's the International Telecommunication Union, or ITU, and the T stands for Telecommunications Sector. It is a United Nations agency. It is responsible for managing and promoting information and technology issues. The ITU is a global point of focus for both governmental and commercial development of networks and related services. The ITU was formed in 1865 as the International Telegraph Union to develop international standards for the emerging telegraph communications industry. The ITU became a UN agency in 1947. It was renamed the International Telegraph and Telephone Consultative Committee, or CCITT, in 1956, and eventually adopted its current name in 1993. ITU headquarters are in Geneva, Switzerland, And memberships include 193 member states, or somewhere around that number, I don't know exactly, and more than 700 sector members and associates. The oldest, most recognizable activity of the ITU is its work developing standards. The IT telecommunications sector, ITU-T, which I mentioned earlier, performs all ITU standards work. The ITU-T is responsible for ensuring the efficient and effective production of standards covering all fields of telecommunications for all nations. The ITU-T also defines tariff and accounting principles for the international telecommunications services. Timeliness has become an important focus on ITU-T standards. In 2001, the organization overhauled its antiquated standards development procedures to reduce by 95% the time required to create standards. ITU-T calls the international standards it produces recommendations. They become mandatory only when adopted as part of a member state's national law. Because the ITU-T is a UN agency, its standards carry significant international weight. Even though ITU-T calls its standards recommendations, they tend to carry substantial authority. ITU-T divides its recommendations into 26 separate parts. Let me go back a slide. You see at the bottom of the screen there. 26 different series, each bearing a unique letter of the alphabet. For example, switching and signaling recommendations are in the Q series, which you see on the slide before you. Data networks, open systems, communications, and security recommendations are in the X series. ITU-T has developed and published many communication recommendations that address technical details of all types of communications. Several of the X series recommendations relate directly to information security. Again, this table I'm showing you lists some of the ranges of ITU-T recommendations that relate to information security. Here is a continuation of those recommendations. One of the leading standards agencies in the United States is the American National Standards Institute, or ANSI. ANSI's goal is to strengthen the U.S. marketplace within the global economy. At the same time, it strives to ensure the safety and health of consumers and the protection of the environment. It seeks to accomplish this goal by promoting voluntary consensus standards and conformity assessment systems. ANSI oversees the creation, publication, and management of many standards and guidelines that directly affect businesses in nearly every sector. ANSI standards cover such business sectors as acoustical devices, construction equipment, dairy and livestock production, and energy distribution. ANSI was formed in 1918 through the merger of 5 engineering societies and 3 governmental agencies. These groups merged to form the American Engineering Standards Committee, or AESC. In 1928, the AESC became the American Standards Association, ASA. And in 1966, the ASA reorganized and became the United States of America Standards Institute, or USASI. Finally, in 1969, the USASI became ANSI. Today, ANSI is composed of government agencies, organizations, or educational institutions, and individuals. ANSI represents more than 125,000 companies and 3.5 million professionals. ANSI produces standards that affect nearly all aspects of IT. Unlike other organizations that specifically focus on engineering or technical aspects of computing and communication, ANSI primarily addresses standards that support software development and computer system operation. The European Telecommunications Standard Institute Cybersecurity Technical Committee, or ETSI, TC Cyber, develops standards for information and communication technologies, or ICT, that are commonly adopted by member countries in the European Union, or the EU. ETSI standards cover both wired and various wireless communication technologies. They have more than 800 member organizations from 66 different countries, and ETSI is officially recognized by the EU as a European Standards Organization. In 2014, ETSI organized a Cybersecurity Technical Committee called TC Cyber, and TC Cyber centralizes all cybersecurity standards within ETSI committees. The TC Cyber standards are intended to result in international standards that will initially be adopted by member EU states. These standards initially focus on security issues related to the internet and the business communications it transports. The entire organization proposes standards to enforce privacy and security for organizations and citizens across Europe. Although any results published by TC Cyber will be European-centric, they will likely have far-reaching effects and impact far beyond European organizations. Next is ISO 17799 withdrawn. This is a former international security standard that has been withdrawn. It wasn't withdrawn because anything was wrong with it. In fact, it was so well received and successful that it was completely updated and turned into a new standard with a new name. You will learn about the new standard in just a few minutes. Because ISO 17799's original form was such an important information security standard, it is important that you understand it. And by the way, it's on most exams as well. This standard documents a comprehensive set of controls that represents best practices in information systems. The standard actually consists of two separate parts. You have ISO 17799 Code of Practice, which you see in the middle of your screen, and you have BS 17799-2, Specification for an Information Security Management System. The main purpose of the standard is to identify security controls needed for information systems in business environments. The standard originally appeared as the DTI Code of Practice in Britain and was later renamed BS 7799. It did not gain wide international popularity due to its inflexibility and overly simplistic approach to control. Developers released version 2 in 1999 to address the standard's weaknesses. Developers submitted the standard to ISO for accreditation and publishing. ISO published the standard as ISO 17799 in 2000. Interest in the standard increased quickly. Several companies began providing tools and services to help implement ISO 17799. It quickly became the predominant information security standard. ISO 17799 gave many organizations a framework on which to build their security policy. Full compliance with the standard quickly became a goal. It also became a differentiator among competitors. The standard enabled potential customers to reevaluate organizations on their efforts towards securing data. The ISO divides this standard into 10 major sections. You have security policy. That's a statement of management direction. You have security organization. That's the governance of information security or how information security should be enforced. Next is asset classification and control. This is procedures to classify and manage information assets. In personnel security, you get guidance for security controls that protect and limit personnel. For physical and environmental security, you have protection of computer facilities. In communications and operations management, it focuses on managing technical security controls in systems and networks. In access control, it gives you controls that limit access rights to network resources, applications, functions, and data. For system development and maintenance, there are guidelines for designing and incorporating security into applications. For business continuity management, you get protecting, maintaining, and recovering business critical processes and systems. And finally, for compliance, it gives you guidelines for ensuring conformance with information security policy, standards, laws, and regulations. A newer standard, ISO IES 27002, has superseded ISO 17799. But again, as I said, you probably see it on Security Plus and CISSP exams. 27002 provides a generic information security standard accessible by all organizations, regardless of size, industry, or location. Although ISO/IES 27002 replaced the withdrawn ISO 17799, you're going to still see references to ISO 17799 as a leading information security standard. ISO IEC 27002. So this standard appeared in 2005 as an update to the ISO 17799 standard, as I just explained. Originally named ISO 17799:2005, ISO changed its name to ISO/IEC 27002:2005 in 2007. This was to conform to the naming convention used by other 27000 series ISO IEC standards. The ISO IEC 27000 series is a growing family of general information security standards. ISO IEC 27002 is Information Technology Security Techniques Code of Practice for Information Security Management. That's the title. Like its predecessor, 27002 provides organizations with best practice recommendations on information security management. The standard directs its recommendations to management and security personnel responsible for information security management systems. Information security is within the standard of the context of the CIA triad. Remember, CIA is for confidentiality, which is ensuring only authorized users and no one else can access data. Integrity, which is ensuring only authorized users and no one else can modify data. And then availability, ensuring that authorized users have access to information when it's requested. So ISO 27002 expands on its predecessor by adding 2 new sections and reorganizing several others. The ISO divides the standards into 12 major sections. I won't go through all 12 standards, but it added risk assessment and human resources security. The standard specifies and outlines the recommended security controls within each section. Most people regard the information security controls as best practices. These best practices provide methods of achieving each objective. 27002 also provides guidance for implementing each of the recommended controls. All right, let's move to the payment card industry data security standard, or PCI DSS. So PCI DSS is an international standard for handling transactions involving payment cards. The Payment Card Industry Security Standards Council, or PCI SSC, developed, publishes, and maintains the standard. PCI DSS is different from other standards you've seen so far. Some of the largest payment card providers in the world form PCI DSS. These vendors include Visa, MasterCard, Discover, American Express, and the Japan Credit Bureau. Each of these organizations had its own standard for protecting payment card information. These organizations combined their efforts and published the first version of the PCI DSS in December 2004. The latest version, PCI DSS version 3.2, was released in April 2016. Now, there may be another version out there. I have to take a look at that. They created PCI DSS to protect payment card users from fraud and to preempt legislative requirements on the industry. That means they wanted to police themselves and didn't want the government policing them. It requires layers of controls to protect all payment card related information as it's processed, transmitted, and stored. The standard applies to all organizations that participate in any of the processes surrounding payment card processing. Compliance with PCI DSS standards is a prerequisite for doing business with any of the member organizations. If any organization violates PCI DSS standards, it can lose its ability to process payment cards. In most cases, non-compliance results in fines and/or audits that are more frequent. Habitual offenders may find their processing privileges revoked. For most organizations that depend on payment cards as means of receiving payment, compliance is a business requirement. The rules with which an organization must comply depend on the number of payment card transactions the organization processes. Organizations assess compliance at least annually. Organizations that handle large volumes of transactions must have their compliance assessed by an independent qualified security assessor, or QSA. Organizations that handle smaller volumes of transactions can choose to self-certify using a PCI DSS self-assessment questionnaire. PCI DSS versions 3.2 defines 12 requirements for compliance, organized into six groups called control objectives. You should look those up and be familiar with them. So, a number of organizations define standards that document technical specifications or other specific criteria for use as rules, guidelines, and definitions of characteristics. Organizations and industries also use standards to ensure that products and services are consistent. The ability of different products from different organizations to work well together depends on standards. As the IT industry advances, so does the need for new and updated standards. In this lesson, I taught you about some of the standard organizations and a few standards that directly affect information security. Research these standard organizations and familiarize yourself with their work. It's likely that you're going to see them again. That's it for this one, and I'll see you in lesson 13.